In this video and in this exercise, we look at how measurements using the density bottle can be used to determine the relative density of a solid material or body. Now we have this question here and we are asked to find the density and relative density of a solid B, given the density of water as 1 gram per centimeter cubed. Now, first of all, we have been given the density of the bottle as 30 grams that has a volume of 100 centimeter cubed. So let's have a density bottle of mass 30 grams and volume of 100 centimeter cubed. So we have an empty density bottle over here with mass 30 grams and volume of 100 centimeter cubed. Now we are told in the question that when the density bottle is completely filled with liquid A, it has a mass of 100.5 grams. So we have a density bottle here which is filled with liquid A. And this weighs 100.5 grams. Now we are told that solid B is put into the empty bottle, and when weighed, the reading shows 66.0 grams. So let's have the density bottle with solid B put into it. So we have the empty density bottle with solid B put into it. And we are told that it weighs 66.0 grams. Now, lastly, in the question, liquid A is added to the solid until the bottle is completely filled. So let's have liquid A added to the solid until the bottle is completely filled. So we have liquid added to the solid until the bottle is completely filled. And we are told it weighs 120 grams. So we have 4 scenarios here: scenario A, B, C, and scenario D. Now, so from scenario B, the mass of the liquid A is equal to grams minus the empty density bottle. So we have 70.5 grams of liquid A that fills the empty density bottle. Now, since the bottle is 100 centimeter cubed, it means that the volume of liquid A is 100 centimeter cubed. So this implies that the density of liquid A is given by which is so this is the density of liquid A. Now from scenario C, since the empty bottle is 30 grams, it means that the mass of solid B is 66 grams minus the 30 grams. We are going to get the mass of solid B. So the mass of solid B is 36 grams. Now from scenario D, the mass of liquid A added is given by is given by 120 grams minus will be given by 120 grams minus 66 grams. That will give us the mass of liquid A added over here. So it will mean that the volume of liquid A added is the mass of liquid A added over the density of liquid A, which we determined over here. The density of liquid A is given by 0.705. So we're going to get 76.60 centimeter cubed. Now the total volume of the density bottle is 100 centimeter cubed. So if the liquid A occupies a volume of 76.64 centimeter cubed, then it would mean that the volume occupied by solid B will be given by so this is the volume occupied by solid B. Now, alternatively, the volume of solid B can't be calculated. Now, when liquid A completely fills the density bottle, it has a mass of 70.5 grams. Now, in scenario D, the mass of liquid A is 54 grams. Now, the difference between the 70.5 grams and the 54 grams that is added to fill the density bottle will be the mass of liquid A that would fill the volume occupied by solid B. So the mass of liquid A that will fill the volume of solid B will be given by so it means that the mass of liquid A that will fill the volume of solid B is 16.5 grams. And that would mean by implication that the volume of liquid A that will fill the volume of solid B the density of liquid A has already been determined as 0. So we're going to have and so that will mean that 23.40 centimeter cubed of liquid A would have occupied the volume of solid B. So this is the volume that solid B of mass 36 grams would occupy. So that will mean density of solid B is given by 36 grams, 23.4 centimeter cubed, and that is given by approximately 1.54 grams per centimeter cubed. It will mean that its relative density is given by the density of solid B over the density of water. So we're going to have The density of water is 1 gram per centimeter cubed. So we have the relative density of solid B as 1.54. Relative density is a ratio and it has no units. So the density of solid B is 1.54 grams per centimeter cubed, and its relative density is 1.54. So this is the end of my video. Thank you very much for watching, but keep watching.